Hey everyone, this is Group 2, including me, Tushar Saini, Sahaja Priya, and Bhargavi Gangapuram, and we are going to show you our final project for CS653 blockchain programming. Our project topic is called CrowdCoin. It is an Ethereum smart contract web application that allows people to gain funding for their projects in a decentralized manner.
Hi, my name is Sahajapriya Bonagiri and I will be explaining about what problem our project solves and how it solves it. To start with, let's focus on what problem our project solves. Our blockchain application focuses on the problem related to crowdfunding campaigns. For example, websites like Kickstarter allows you to help raise money for the initial prototype of your project via donations. The idea is people that are donating to your project are expecting a return in the future when the project is ready. However, once enough money is raised, there is no possible way of enforcing that the money is raised is going towards the project. This has resulted numerous scams about project being fraud where person or people responsible for the project takes all the money for themselves and not on the project itself, basically stalling the money. There is no way to guarantee that the money being raised will actually go towards a project or not, and there is no way to enforce it either. The picture shows what a normal scenario looks like in an ideal world where the project manager was making sure that the money raised is going towards the project. Now let's see how our contract eliminates the problem prescribed in the previous slide. Contributors will no longer be sending their money to the project manager. Instead, they will deposit their money into an Ethereum contract. The Ethereum contract will regulate who can send money to its contract. Once the project manager decided that he or she want to use the money, he or she will essentially need to put out a spending request in the contract, which will attempt to withdraw the money from the contract and send it to an external address. Once the spending request is generated by the manager, all of the people who have contributed to the contract will vote whether or not to pass the spending request. This makes it a decentralized platform because everyone has equal power in terms of where their money is going and whether they agree on the transaction or not. It allows to make sure that money raised is actually going towards the project. If the majority allows the spending request, then the request goes through.
Hello, I'm Bhargavi Gangapuram and I will be discussing the basic design of our smart contract. So firstly, I'm going to explain what variables we have in our contract and what do each one of them do. So there are four main variables in our contract which are manager, minimum contribution, approvers and the request. So the variable type of manager is address and it's the address of the person who is managing this campaign, and variable type of minimum contribution is unsigned int. So it's the minimum donation required to be considered a contributor or an approver. So moving on, the approvers variable type is array of addresses and it consists of list of addresses for every person who has donated money. So same goes for the request, which is also an array type and consists of list of requests that the manager has created. Now let's take a look at the main functions of our smart contract. So there are five main functions for the contract, that is campaign, contribute, create request, approve request and the finalize request. So campaign is a constructor function that sets the minimum contribution and the owner contribute is called when someone wants to donate money to the campaign and become an approver. So create request is called by the manager to create a new spending request, and approve request is called by each contributor to approve a spending request. So after a request has gotten enough approvals, the manager can call finalize request to get money sent to the vendor or for project development.
Hey everyone, this is Tushar again, and now I'm going to demonstrate our project to you. So I'm going to go and click on this YouTube link, which has a video of me explaining our project and demonstrating it. Hey guys, it's Group 2, including our web application on localhost 3000. That's where I run my application at, so I'm going to go ahead and
Click on that. So once you actually go to this address, localhost 3000, obviously it's not going to work on your computer, but you should be seeing this. Ignore these two campaigns for right now. These are a result of the earlier testing purposes that we were doing. So we're just going to ignore these. So what we're going to do is we're first going to click on create campaign. Let's say Tushar Saini wants to create a project for, I want to go to Europe and do some business there. I'm going to click on create campaign. And in order to create campaign, whoever is creating it needs to put a minimum contribution. Same goes for the approvers or the donors who wants to enter the contract. In this case, I'm going to put 100 lei. Make sure where it's important to note that the unit is lei, which is lei less than an ether. So I'm going to click create, and it is going to pop a MetaMask on. Since basically what we're trying to do is include a transaction on the blockchain. And anytime you do that, you have to pay a little bit something. For example, in this case, we have this gas fee. So I'm going to go ahead and confirm. Once I get confirmed, it takes a while for this request to get processed. This is called block time. After a specific number of block confirmations, our transaction gets added to the block. In other words, our transaction gets processed. So this address 0.07f is the address that actually created the campaign. So if I click over here, this is the campaign that we just created, view campaign. See, this address is the address of the manager who actually called this contract, who actually made this contract. So if you again go back to MetaMask, you will see 0x070x07. That's the same address. Over here, we'll see that your number of requests, number of approvers, campaign balance, minimum contribution right now is 0. So let's say I want to contribute to my own project, and I will contribute 0.002 ether. I contribute, and again, MetaMask is going to pop up. It's going to ask me, hey, do you actually want to go ahead and do that transaction? Absolutely, confirm. 0.002. Now let's say somebody else wants to contribute to this project. And real quick, guys, a really important thing to note here is that I'm using a Ring-B test network. Basically, it's a testing network, and it allows us to the name is pretty self-explanatory. We're testing it. So it gives us fake ETH. Whatever ETH that you're seeing here right now associated with this account is not real money. So just something to keep in mind. So I'm going to change my account, and you can make as many accounts as you want. I'm going to click on this account. I'm going to copy this address, and I'm going to contribute 0.001. Actually, let me do 9 ether. So I'm going to click on contribute. Again, MetaMask is going to pop up. This time, I'm the one who's I'm using a different account to pay. Confirm. Okay. See, anytime now. There you go. Our total campaign balance for this is 0.092. And anytime you can click on here, it will take you back to campaigns. These are different campaigns. I'm going to go back to this campaign. Contribute again, MetaMask. Just because I don't have enough balance, it says insufficient funds. So I'm just going to reject that. And instead of that, I'm just going to do a very small amount. But hopefully, I should have enough ether for that. Let me change back to my manager account real fast. Address associated with this manager is same. So I'm going to click on view request. Let's say I want to withdraw the money as a manager. So I'm going to click on add request. And only a manager is able to add a request just because he or she actually runs the project. The description, I'm going to say buying tickets or business related. Be able to include the transaction. So it should work now. See, perfect. It's really important to understand why I was getting the error before. Is because I was trying to create this request from a different account, and that account address was not the same as the manager address. So I changed back to the account that has an address associated with the manager, and that is why I was able to create the request. Because the whole purpose of this is to actually allow the manager to create the request. So I'm going to click on confirm. So that much ether will be going. So again, it takes a little bit of a while for the request to get processed through. Whew. Processing. So once the request gets sent through, we have this table telling us how many approval accounts we got. The number here is the total number of approvers. As you will see here, it's 3 approvers. Click on request. Now, as manager, remember I contributed too, so I am considered as an approver automatically. So I'm going to approve this transaction. It's going to ask me again because we are trying to change the state of a blockchain. That's why this pops up. Anytime you do that, you have to. I'm going to go back to view campaign, view request. See, now the approval is 1. We need 1 more. So I'm going to change back to the different address that I have because he is in charge of the contract. So only this address will be able to finalize the request. Again, the request is that we are sending this money to hypothetically, in this case, I'm assuming I am the person associated with the project. So I'm confirming the transaction, and it should be sending it soon. So I'm going to go back here. I'm going to go back to this balance, and my balance should have increased. Okay, I'm going to change it back to this. See, it was 0.0145 earlier, it's 0.0146, and the balance has been deducted from here as well. That amount of ether has been sent from this whole ether contract to my address. That is basically it, guys. Obviously, I could have made this a little bit more beautiful, but at the time constraint we had, that's what we were able to achieve. And these are the old